Hi, I'm James Wong, and this is the demo for my finite state machine. And so the flip-flop has a clock which is connected to 0 as an out in my deck, and the reset is connected to 1, and the input, the decoder, is connected to output 2. And the reading pins are 4 and 5, and those are connected to the outputs of the flip-flop, and that's Q0 and Q1, respectively pin 4 and pin 5. So this is the state diagram, and we can start by initializing the reader and the writer, and by keeping pin 1, which is the reset, on. Since it is an active low, it always keeps the reset low, so I can proceed with my finite state machine. According to the state diagram, now we are at state A because nothing is lit up, and so if with the input low, clocking it will lead us to state B. And at state B, as you can see in this route, regardless of having the input 0 or 1, the state is going to transition to C. And so there are 2 routes, and we'll leave it off for this time. And boom, it goes to 5, goes to state C. And at state C, there are 2 ways as well. If you leave the input as on and then you clock it, it goes back to B, which is this route. And before we tried, if we transition from B to C, either input works, and we tried it to being low, and now let's leave it high and do it again. It goes back to C, which means this route is completely verified. And finally, we can try to leave the input low, so this should lead us back to stage A. And okay, now we're back to stage A because nothing is lit up. And to lastly have this, we can just try to clock it, and oops. So when we're at stage A, if we have our input high, it will go back to itself, which works. So that sums up all my finite state machine. Thank you.